a suitable right-angled triangle, find the exact minimum distance from the point 8, 3 to the line with equation 2x minus y plus 2 equals 0. So this is quite tricky. As you go through the course, it may be that vector methods are more effective to solve this, or you feel more comfortable. Right now, we don't have any vector methods. So we're going to draw a picture and see what we can do from there. So the first thing, I want to be able to sketch these two. I am going to use squares just to make the plot look a bit better. But if you don't have any squares, you could just space it out reasonably well. I would suggest sort of counting squares mentally, just so that the sketch looks good enough to use to make inferences with. So if I want to draw this, I would say it's much easier just to make y the subject. So that would be 2x plus 2 equals y. So y equals 2x plus 2. So then if I want to draw that, it becomes a lot easier. So trying to stick to my squares. X and y. I'm interested in the point 8, 3. So 1, 2, 3, 4, 5, 6, 7, 8, and 3, 1, 2, 3. So 8, 3 is there. And I want to draw the line y equals 2x plus 2. So that will have a y-intercept of 2, and every time it will go along 1 and up 2, along 1 and up 2, along 1 and up 2. So it's going to go something like that. And I want it to do the same in the other direction as well. Okay, so we have our line, y equals 2x plus 2. And I'm interested in the shortest distance from that line to that point. So the shortest distance is going to be when they are perpendicular. It's not the most amazing drawing, but basically I want this angle to be 90 degrees. So that would be 90, that would be 90. And this is going to be our distance d. Right, so now the plan is to try and draw some triangles, see what we can do with this. Okay, so I'm going to form some triangles. I've been quite fortunate that using the tools I've got, I was able to recognize that I haven't left myself enough room at the top, so I've just moved everything down. The reason for that is so I can extend this line, and I want to be able to draw a vertical line up. So I want to be able to draw this line until it meets there. I also want to draw a horizontal line. And I've got a point here. Now actually, I'm just going to give these points names. So maybe just A, B, and C. A, B, and C. Given that we weren't actually told the letters of any points. So what I'm going to do, we're going to get two different expressions for the area of triangle ABC. And then we're going to hope to find the value of D by forming and solving equations. So I need to know the coordinates of A and the coordinates of C. So the coordinates of A, remember it lies on the line y equals 2x plus 2, and it has a y coordinate of 3 because we have that horizontal line there. So this is where 2x plus 2 equals 3, just like that. So that must mean 2x equals 1, and x must equal 1/2. So A, here, A must be at 1/2, 3. Similar approach for C, but here we know the x coordinate is 8, so y equals 2 times 8 plus 2, which is 16 plus 2 equals 18. So that means C is at the point 8, 18. So as I was saying, I'm going to get expressions for the area of this triangle. I hope to form and solve an equation. So area of ABC. Remember, it's a triangle, so it's half base times height. So if we take, well, we know we've got a right angle here, so it could be half times AB times BC. Half times AB times BC. That's one way of doing it. AB is going to be, well, it's 8, so it's horizontal line, so it's 8 minus a half, so equals a half. 8 minus a half, so that's 16 over 2 is your 8, minus 1 over 2, times BC, well, that's a horizontal line, so we're using the y's. C has a y coordinate of 18, B has a y coordinate of 3, so it's going to be 18 minus 3. So that would be a half times 15 over 2 times 15. So that could be, well, 15 times 15 over 2 times 2. So that could be 225 over 4. So now we know the area of that triangle. Then what we could do, if we get the D involved, we could, if we consider AC as the base, so if we take AC as the base, and then D as the height, they should, if we use those as in a half times AC times D, it should give us an answer of 225 by 4 because it's finding the area of exactly the same triangle. So we could also say area equals a half times AC times D. And we know that equals 225 over 4. So D is just D, we're going to solve for it. AC is a bit more complicated because we're going to have to use the distance formula. So AC is the distance between A and C. We know A is at a half and 3, and C is at 8, 18. So let me write that down, so I'm not sure. So A is at a half, 3, and C is at 8, 18. So that means AC is going to be the square root of, remember it's x2 minus x1 squared, so 8 minus a half squared, well 8 could be 16 over 2, minus 1 over 2, so 8 minus a half squared, plus, and we do the same with the y's, that's easier, 18 minus 3 squared. So that would be equals the square root of 16 over 2 minus 1 over 2 is 15 over 2. 15 over 2 squared is 15 squared, 225 over 2 squared, 4. So 225 over 4 plus, well then you've got 18 minus 3 is 15. 15 squared is 225. 225 over 1 must be 450 over 2, which would be 900 over 4. Okay, so that is going to be the square root of 900 plus 225 would be 1,000, 1,125, 1125 over 4. So now the area is a half times AC times D. So a half times, well, it's the square root of 1125 over 4. Well, we could say that's root 1125 over root 4, which is another 2. So a half times AC times D, and we know that's equal to the area of the triangle, which we said was 225 over 4. So now, looking at this 1125, we're hoping that 225, which is a square number, 15 squared, goes into 1125. So if you have 225 times 2 is 450. So that's 1, 2, times 4 is going to be double that, 900. And if we were to add on another 225, that would be 1125. So that would be 5 lots of 225. So that means our equation becomes, if we've got 2 times 2 is 4. We've just said root 1125 is going to be the square root of 225 times 5. So you've got root 225 times 5 over 4 times d equals 225 over 4. Okay, so this is coming together quite nicely. We can multiply through by 4, so get rid of the denominators. So root 225 times 5 can be root 225 times root 5 times d equals 225. So that would be, square root of 225 is 15, so 15 root 5d equals 225. We know that 225 could be written as, well, it's 15 squared, so it could be 15 times 15. So if we divide through by 15, that would leave a 15 there. So that would mean root 5d equals 15, so d must equal 15 over root 5. And we're looking for the shortest distance. I don't like leaving square roots on the bottom, so we're going to rationalize. So we're going to times by root 5 over root 5. So that would be d equals 15 root 5 over 5, which would be 3 root 5. 15 over 5 is 3 over 1. So shortest distance, remember what we're actually finding. Let's write that down, 3 root 5. We are finding, if we go all the way up, you do sometimes get lost, we're finding the shortest distance, the minimum distance from the point 83 to the line. So d is going to be, shortest distance is 3 root 5. We don't have units, so we just write units. Okay, 3 root 5 units.